So now we're going to look at how to actually do overloading in classes. So we've seen already how we can overload two functions that have the same name, but they have different types or numbers of parameters. We've seen this already. And we can actually do overloading of functions in a class as well. But one thing we haven't seen is we actually haven't seen how overloading can be used to overload operators. For example, if you want to compare, like we did in our last class example, we compared. Did we do any comparison? No. Okay. In any case, if we wanted to compare, for example, yeah, here's a good example: the less than operator. Right here, the less than operator is defined for what? Is being used to compare to what? Integers, right? But we can also use the equals operator, right? Double equality compared to integers to see if they're equal. We can use the double equality to compare two strings and see if they're equal. So we can use it for any of these primitive types or defined types. Now, one of the really powerful things you can do in C++ is when you create your own classes, you're essentially creating your own user-defined types, right? So we now have a person class. We can create these person objects. And just like with integers, strings, and so on, we could also overload these operators like the doubles equals to also have a meaning when we actually pass in person or people objects instead of string or integer and so on. So that's something that's really powerful we could do with overloading operators. So what I want to do is I want to show you how can we can overload the double equals operator that we use to compare ints, compare strings, compare booleans, all these other things, to be able to compare two people. And the example I gave in class was we have two Michaels in class. And how would we actually be able to compare a person object with the information for one Michael versus another? And if you guys don't mind, I'll actually use your example. It will be recorded in the YouTube video. Are you guys okay with that? Okay, you can give me fake names if you want. Just keep your first name the same. You can give me fake last names and ages and stuff if you're worried about identity theft and stuff. We haven't put birth dates in, so. Okay, so the first thing I want to do is I want to show you, let's actually just, if we didn't want to think about if we didn't want to think about overloading operators, how would we actually go about being able to see if two person objects are equal? Or if one person object is equal to the one we currently have. So remember, every person object, we want to say, okay, is this other object equal to me? Is what we're really asking. So if we wanted to do that, we could say is equal and pass a person object in. Okay? So then we could do something like down here. We could say if P1 is equal so this is basically just checking if person 1, and what was person 1 in this case? Some random person, right? We're saying, okay, person 1 saying, okay, is person 2 the same as me? Right? Well, let's actually set some details here. So if we set person 1's first name equal to be I'll use this instead of using the Michaels, but it's the same thing. Right? We've got the age set. We can do P1 set student to false and P1 set employed to true, right? So now, if we wanted to look at, if we have P1 and P2, what's different about P1 versus P2? Age is different, last name is different, and one of them is employed, one is not. But they're both named Oscar, right? So what we could do is we could do this. We could say if P1 is equal P2, what this is really saying is P2, is that person equal to the current person, the P1? Does that make sense? You with me? And we could print out, they are the same. Now, let's actually implement this is equal function. So if we take this here and we implement it, the bool is equal. We have to make it, it's part of the person class. So what we're going to just do is, one simple thing we could do is we could just say, what could we do as a starting point? We could just say first name equals P dot first name. Or actually in this case it's P dot get first name, right? No, I'm just saying as a simple thing we could say first let's just compare their first names. Right? We could try this. I just want to, as a very simple example, let's just try this. So if we actually now compile class example 2, oh, what happened here? Okay, so yeah, because I'm actually doing this as a person, let me just change this here. Yeah, sorry, what I needed to do was this. Oh, and I had a compile error here. No one caught that one. Okay. So yeah, I actually, sorry, what I was supposed to do here is pass in the reference, the object that's being referenced by the pointer. So what this is going to do now is, if we actually run it, is this is going to say that they're the same. So it's going to say, hey, the P1 person and the P2 person are the same. Okay? Does this make sense? Are they the same? They're not, are they? The first name terms, but we just have a very bad definition of is equal here, don't we? So what we could do is we could put a really long expression here. How would we implement this to check all the different member variables? Yeah, we could do that. We could say if first name, if the first names are the same and the last names are the same and the ages are the same, and even if their employment status is the same or something, we could do that. We could also do an if statement where we say if the first names are different, return false. Else, if the last names are different, return false. Else, if the next one is different, return false. And then the last one being if all of them come back true, we return true. That's another way we could do this. Yes, Michael?
Because person has so many set variables, like it has a first name, last name, age and stuff, is it possible in one line to reference all of those in one? And be able to be like person P1 is equal to P2 kind of thing?
Well, that's what we're implementing. So we're implementing this so that we'll be able to do that. Now, we could do things like toString function, where we generate a string containing all of them in the same order and then compare the two strings. That's possible, right? But what we're going to want to do here is we're going to want to basically do, okay, if the first names are the same and last name is the same, and what else? Age is the same. Do we want to check their other status, or is that sufficient for now? This is probably fine. Do you want to check if they're a student and stuff too, or just say that? Does that sound good? How many of you want to do the other ones? Nobody cares. Okay. Sweet. So that's what we're doing now. So let's just try this definition if is equal. Will this print out they are the same? It shouldn't, right? They are the same. What? Do they have the same first name and last names?
Yeah.
Did we do something wrong? Did we not compile it? They are the same. What did we do wrong?
Why don't you just have like one Boolean and then compare it all? You get to the point where it's not the same, return false.
If this and this and this are the same, returns true. If any of them are false, it should return false. What happened there?
The first name equals.
What?
Yeah, just print this first name equal. Do a bunch of print statements in there, and we can see what first name and p dot get first name are. Maybe we're passing the exact same person. We don't even know.
There's a thing, something I did that is actually deliberate, and okay, let me tell you. The problem is not in that. The problem is in our main function. Take a look at the code. What did we do, Alex? Yeah, we actually deleted P1 up here. And what did I tell you about the cleanup and stuff of dynamic variables? It may be that the memory gets reused. So it may be now that P1 and P2 are the same memory address. So we can't guarantee it. So if we get rid of the P1 and we delete it after, we can guarantee that the variable works. So let's try this. Will this fix our problem? All of a sudden, what? Not equal anymore. So that was a case where we tried to use the pointer variable after we had deleted it. It still pointed to the same location, but that location had been written over. In fact, by the other variable. So it was saying P1 and P2 were actually pointing at the same thing. Does that make sense? Do you get what I'm saying? Yeah? Anyone else not get it? Get it? I can take a break and show you on the board if that helps. Do people want me to show it or not? Everybody seems to get it. Okay, cool. So that's the is equal. Now, the thing is, though, of course, what I'd really like to be able to do is this. I'd really just like to do this. Just be able to say, hey, is person 1 equal to person 2? With the operator double equals, right? Because that's what we would do if it was strings or anything else. So what we're going to do is we're going to now overload that double equals operator, which has a meaning when we're using integers. It has a meaning when we're using strings and bools and floats and other things. We're going to now give it a meaning when we have a person object on either side. So if we go back up here, how would we actually implement this? Well, it turns out this is one of those things where you have to know what the definitions are for operators, but I'll give it to you. So one of the things we can do here is we can do what? We want to return a bool, right? Correct? We want to say operator equals. That's the name of the function. And we're going to pass the person P. So we're doing it exactly the same as is equal, only it's this now.
Keyword or like
Operator equals, operator is a keyword. Yeah, this is a special way of naming a function for an operator. So if we go down here now and we implement this, and of course it's part of the person class, right? If we just took this and put it in here, does that make sense? What? So will this work now? What? Let's try to compile this. It compiles, and what happens? Well, it didn't say they're equal, but what about if we did this? P2, P2. What should that display? Right? So if we did it this way, we should get that this is equal, right? And yeah, it does. So we've now defined a definition. We've now overloaded the double equals operator to work with this. Is that kind of neat? So we could also do things like less than and greater than, right? What about output? Wouldn't that be cool if we could just output P2 at Cout? We could just go angle brackets output rather than having to go P2 print. We could overload that operator too, couldn't we? Does anyone not get what I just did with this equals? Is anyone really confused?
Yeah, what is that operator thing?
Okay. So this line here is basically what this is saying is there is already a definition for the operator double equals, okay? It's already defined for integers, strings, and other data types. So the function operator equals, we are going to overload it so that when a person object is passed in, it will compare it to the current person object and tell you if they're equal. Okay? Now you may be confused because you may say, wait a second, when I look down here, double equals, how many parameters would you think this function should have? You probably would think it has 2 because it has the left side and the right side. Correct? But really what you're saying is P2, or in this case P1, call the double equals function with this as a parameter.
If you did the arrow, would that have the exact same? Like if you did. Would it
If you think about it, it's sort of the same as this. Okay? But that does not compile. Actually, you wouldn't use the star there, sorry. That is the same thing. So this is actually shorthand, right? So if I just do them both this way and compile it, it works, right? So that's really what you're doing. So we're interested in comparing these two. And this is just shorthand for any operator defined an operator function that you overload. You actually can just put the operator this way. Make sense? Kind of. Do you need to see another example or?
writing out the actual thing may make it a little bit
What?
Doing the P1 pointing to the operator, that made it make sense.
This made it make more sense? Okay.
So the greater sign, just put greater instead of the equals.
Right. But all of these sort of have definitions. So let's do another example of an operator. I'm going to overload, which operator? Actually, you know what? Given the time, I'm not going to overload. Yeah, let's overload maybe the less than. Does that sound okay? Yeah?
Could you overload the string operator for get or send? Like instead of using set, is it possible to overload the string operator to do that before?
No, you wouldn't want to do that. And let's talk about that offline. But you wouldn't want to do that. Just to show how this works, what we can do is let's actually implement the not equals operator, because the less than and greater than, how do you know if one person is less than another person? How are we going to determine that? Age? Is that how you want to do it? Okay, we can do it that way. So we also want to do a less than operator, right? So if we wanted to do that, if we took something like our function that we have right now, and we did less than, we could say, now I'm going to do this a little bit different. I'm going to say how do we want to do this? Do you want to just do age only?
First name first, and then first name is equal.
Can we use the less than operator with strings? So what I would say is maybe the easiest way is to do it by age. Otherwise, you go to name if the ages are the same. Does that sound reasonable? So maybe what we can just say is if age is less than p.age, return true. Okay? Return true, sorry. Else, if age equals p.age, what are we going to return? If that's the case, then we're going to check inside of that if if get name is less than p.get name, we're going to return true there. Does that make sense? And otherwise, if the names are the same, for example, what are we going to do if the names are the same as well? If the age is the same and the names are the same, we'll return false, right? We'll say that this one's not actually less than. And then finally we'll do another thing here, an else return false. So what we're doing here is we are basically saying, first we're determining if one person is less than another person based on age. Okay? So if the age of the first person is less than the age of the second person, we're going to return true. Yes, it is the case. Now, if the ages are the same, we're going to return true if the person's name is, so we're basically going to see if one name is less than the other name. Yeah?
So we can get age, not just dot age.
Oh, right here? We should. That's a mistake. And so if the ages are equal, then we're going to check about the names. And if the names have a difference, one is less than the other, then we're going to return false. Maybe is that too complicated for you guys? We could just cut this out completely. And just say if the age of the first one is less than the age of the second one, return true. Otherwise, return false. Make sense? So if their ages are the same or the age of the second one is greater, then it's going to return false. So in our case, we have what we can do now is we can do things like if star P1 is less than star P2, we could see out P1 get name is younger, right? Does that make sense? And in our case, is P1 actually younger? Well, P1's age is 20, and P2's age is 108. So if we do this, let's see if it works. In fact, it says Oscar A. Grouch is younger than Oscar the Grouch. Did I go too fast then? Did I go too fast for most of you?
I can keep up with it.
Too fast?
I think it makes sense, but
Okay. What I'll do is I'll go back and explain it, the less than, just so everybody's clear on it. So what I was doing was I wanted to overload the less than operator so that I could compare one person with another person. Does that make sense? Okay. And the way we're going to compare it is based on the age of the person. So if P1's age is less than P2's age, this should return true. If the ages are equal, or P2's age is actually the lower one, it'll return false. Okay? So this will only return true if P1 is in fact younger than P2. And it does, we can see this here that it did, and that's because in our case, our first person, P1, Oscar A. Grouch, was 20 years old, and Oscar the Grouch was in fact 108. Okay? So, if we want to look at how this is implemented, the first thing we needed to do when we're overloading an operator is, inside of our class person, we need to declare the function we're overloading. And for operators, we use one of these special operator functions. And for the comparison, because this is part of the person class, whatever the left hand is, that's the object that we're calling this from. So we're calling P1 is less than P2, and P2 will be passed as the parameter. And if we go and look at how this actually gets implemented, we can see here that the way this gets implemented is we have an if statement here which checks the left hand, the current object's age, the left-hand side. We check if it is in fact less than the parameters get age. So in this case, we're checking if Oscar A. Grouch is 20 years old is less than 108 of Oscar the Grouch. Or is it less than? Is 20 less than 108? It is, so we return true. Otherwise, we return false. Okay? And as I mentioned before, you can think about these things as this is really the same here. This is the same as if we had called P1 operator less than star P2. Okay? So what we're really doing here is this is the less than operator, and we're saying call the less than operator for P1 and pass P2 as a parameter to compare it with. Okay? Does that make sense? Okay. So that's just two examples of overloading operators. What I'm going to show you next time is we're going to look at a different way of overloading. We're going to learn about something called friend functions, and I'll show you how you can implement these operators and other functions as friends of a class as opposed to actually inside the class. Okay? That's what we'll do next time, and then we'll be moving on to the pointers.